For this example, a shoe manufacturer claims that athletes can increase their vertical jump heights using their training shoes, which, if you watched NBA highlights circa a few years ago, probably sounds, well...
We are Boingvert. We create dunkers.
A bit familiar. The vertical jump heights of 8 randomly selected athletes are measured. After the athletes have used the shoes for 8 months, their heights are measured again. The vertical jump heights in inches for each athlete are shown in the table. For alpha equals 10%, is there enough evidence to support the claim, assuming approximate normality, because there aren't that many of them? So, what we have here is our data sets, where if we want to make sure that we're doing this the right way, if we want to check our conditions, the main thing to understand here is that these are dependent samples because we're looking at a connection from one person's jump height before they get the fancy shoes to after. One after the next, where each piece is directly connected from one to the next. Because it's the same person, they're just hopefully jumping higher. Now, otherwise, basic things, we have approximate normalities, the central limit theorem holds, and there's really only one situation in which we're talking about things that could even possibly be dependent. This one, so we're good on that regard as well. From there, if we want to actually perform our test, we need our hypotheses. So, we are claiming, in this case, that the difference is negative, and this might seem a little bit strange. But what we need to understand here is when we're doing these tests, often we'll do before and after, where we make it before the 1 and after the 2, as it were. So when we're looking at a difference, we're taking before minus after. And if we're expecting the heights to get higher, we're expecting after to be bigger. So we would expect the difference to be negative. But really, we're just expecting that there is a difference in one direction. And if I did after minus before, that direction would flip. And hopefully you'll see a little bit in the calculator video where I talk about that. But the point is, making this negative is entirely arbitrary. It's a matter of convention, not a matter of necessity. So just be very careful with that. As long as you know, though, that we're looking for a specific direction, that's the important thing. In this case, it's smaller based on the way that I set it up. Anyway, the opposite of that is that the difference is at least 0. Because it has an at least, that's our null. So our claim is the alternative, as it usually is. Then if we want to talk about our things like the level of significance, as usual, that's our given value here of 10%. Where, like I said, somewhat arbitrarily, we're going to be doing this with a left-tailed test. From that point, we can talk about critical values, degrees of freedom, all of that extra special stuff that we do need. For one, if we want to get the degrees of freedom, since it is the same sample taken twice, we don't need to worry about pooling or unpooling or which one's smaller. No, you just take n minus 1, which in this case is 7. And if you want to get the critical values, critical value in this case, well, that would be another inverse t type of computation, where we're dealing with 10% in the left tail and 7 degrees of freedom. So you would get something in the family of this, which I put myself in a bad spot by not actually writing down on my piece of paper here, but that's what you would get in the most exact way. Fooled myself a little bit. But anyway, from there, I am actually kind of skipping some steps here in terms of getting the test statistic, and the reason why I'm doing that is because the book kind of expects you to pull up some really clunky information, just a large amount of information, frankly, which you got on the screen right now, going through each of those things bit by bit by bit to get your differences, you get your average difference, and all that stuff. No. it's really not worth your time. What you should really do instead is get the stuff in the calculator, work with those table data entry, what's what I'm looking for, computations, and that'll do it much quicker for you, that'll get it more accurately for you, provided you're careful. But you want to do it that way. In any case, from there you're going to want to get your test statistic. I'm going to go ahead with the p-value approach. Critical value approach is still very similar, still the same sort of critical value approach we've always seen, but I like p-values. In either case, we need the test statistic, where that test statistic will have the flavor we see there. In this case, that flavor is something like negative 1.75 minus 0, because we're assuming, kind of, that the mean difference should be nothing, divided by 2.1213, excuse me, over the square root of 8. So our test statistic is approximately negative 2.33. And from that, we get something like this distribution here, where looking at the location of our test statistic and our critical value, which is on that distribution, was not on the piece of paper I was looking at, you can hopefully tell what's going to happen. But because I want to do the p-value approach, we also need the p-value. In this case, that p-value would end up coming in at approximately 2.6%, where most importantly for our purposes, because either our t-score is in the rejection region or p is less than alpha, we reject the null hypothesis. Where the null hypothesis here is the hypothesis stating that the mean difference of before minus after is at least 0. That is, we are rejecting the idea that the shoes either decrease their vertical or do nothing. So if we want to get our conclusion, we would have something to say along the lines of, there is enough evidence at the 10% level of significance to support the shoe manufacturer's claim that athletes can increase their vertical jump heights using their training shoes. Where, to be sure, when you're dealing with this kind of problem, I would still recommend running through this as a t-test of differences, in order to be able to get these numbers as you need, in order to be able to get these pieces. Just run through it carefully where you're sure you put things in the right place, and it'll get you to the right place. But before we finish up with this chapter, I want to get one more example for this section, just to be sure that it's sinking in, or hopefully I do remember to. We'll have to see.